Hello and welcome back. Okay, the next thing I'd like us to address, we have a problem that actually my daughter reported, and she reported that if you take a picture of something and run some of these filters, some of the times they take a long time. And the reason is images like this are actually quite a lot of pixels. So if we pick one of our more complicated filters, we'll say the silly dither filter, and apply that, uh, we're going to be spinning for a while, which is okay, but a bit of a pain in the butt. Now, realistically, if we shrink this image down, you're not going to notice the difference. So from the perspective of the user, that's the thing to do, is shrink the image down and then work with that shrunk down image. So let's create, while this is running, let's create a helper file. Let's call it image scalar, image resize, image resizer. Okay, so this is class image resizer. Oh, and I see our effect finally finished. It took a while. In the init, what I'd like to do is just take a single variable, call it max dimension. Init. And we're going to store that locally. Just copy that, do a let. And now we can go self dot max dimension equals the max dimension. There. Okay. Now, next thing, we want a function that can resize the image. Okay, so resize image. It's called image resizer, resize image. Yeah, that makes sense. UI image is what we're going to take in. So that'll be the image. We'll call that the original. Okay, and it is going to return a UI image. And let's start by just returning the original image. Make sure that everything's appears to be, and no, we have a small problem. We need to go up here and change that to UI kit. I guess we could have added UI kit, yeah. Okay, looking good so far. Now I want to write a helper method, func, called is small enough. Okay. Now that I think about it, this is more of an image shrinker than an image resizer. That's okay. We can add other methods later. Not that we're going to. Okay, so is small enough. We will take a width, which is an int, and a height, which is an int, and return a bool. Right? So this should be pretty simple. We return true if w is less than the max dimension and h is less than the max dimension. So we're making sure that the width and the height are both smaller than the max dimension. Just fix my typo there. Okay. And in this, we can do a quick check. We can say if, actually I think we need the width and height, don't we? Yes. I'm going to go var width equals, so let's take the original, size, and width of that. And that's a CG float, so we need to cast it. We want it to be an int. We also want to do the same thing for the height. Oh, I'm horrible at spelling height. There we go. Right, so we're going to say if is small enough, if the image is already small enough, basically. So the width and the height, width of W, height of H. Okay, if we're already small enough, then you can just go ahead and return the original. And we'll just say already small enough. Okay. Otherwise, we have to, oh, don't need that. We have to determine what the appropriate size is. So I'm going to have it, my algorithm is basically, I'm going to cut the size in half and keep cutting it in half till we find a size that's small enough. Simple, simple, simple. So let's go, while, let's see. Yeah, that's right. While is, well, we're not small enough, do the following. And we'll just take our width and divide it in 2, and our height and divide that by 2. Now we're doing it this way so that we can, we only need to be in the ballpark. We don't have to have an exact size. We just want it to be a little bit smaller, something reasonable. So we're just going to keep cutting it in half until we're in, in a ballpark that works. So, hey, this looks pretty straightforward. We keep shrinking it up till it's small enough. And then we can actually do the shrinking. So here's where we can scale the image. Now, for this, I don't want to take forever here, and you can look this stuff up on the internet. So I've already got some code, and we'll talk through it, but I'm not going to bother you by trying to remember every line from memory. But the algorithm's pretty simple. Okay, scaling to a new size. Okay, we need to pass in, I'm put it in the wrong spot. Let's move it here. Okay, so this is just a private function. Actually, I'm going to hook it up and then we'll talk through it. So what do we want to do at this point? We want to call this method. We want to pass in the original image, and then we want to pass in the new width and the new height. Right? And then we just need to return that. Pretty straightforward. Okay, let's talk through what this is. Actually, it's pretty simple. CG, the core graphics image. Okay, a UI image. We're able to call this CG image to get that core graphics image. And this is a data structure that's more, well, it's very well supported inside the ecosystem here. And then we can just call a bunch of things. Give me how many bits per pixel. So we just look at the original CG image. We say how many bits per pixel, how many bytes per row, what color space is in use, can you get me the original bitmap? And after that, we create a context. And then this is all very familiar. Well, might be familiar. Then we're going to do set context, CG context set interpolation quality. Haha. So how do we take it? How do we scale the images? Basically, you can do fast, or you can do high quality. And this isn't going to be huge, so I'm just going to say give us high quality conversion. Finally, we redraw it using the new width and height, and that'll give us, when we get to this point, we've got a CG image that's been scaled down to the size. So that's a core graphic image. So as the last step, we take that core graphic image and convert it back into UI image. So we're creating a totally new UI image from that core graphic image. Okay, so you don't need to understand all this code. This is just stuff you can get off the internet or look up yourself. But it is kind of like Yeah, you have to look this stuff up. But it's pretty simple. So this is a way of scaling it. Now let's do a quick test. First of all, let's make sure that this is actually working. So let's put it in. We're going to go to our view controller. We're going to create this thing. Var image, I'm going to call it shrinker, equals an image resizer. And I'm going to give it something absurdly small, actually. I'm going to say 64 bits. And the reason for that is I actually want to see it kicking in. So I'm going to take our image shrinker. Oh, and I guess I need to say, do I need to specify the max dimension there? Oh, I'll just wait till I see the error message. Anyways, let's move along. What's it complaining about? What am I missing? Yeah, silly me. Okay, we did need to specify the max dimension label. Okay, let's use the image shrinker. We've got two places where we use raw images. One of them is right up top here. So we're going to call our image shrinker dot shrink dot, is it scale? Yeah, I think it's shrink. Oh, and let's also change the order here. I'm going to take this, move it up here. Oh, didn't mean to hit that button. Come on. Okay, where were we again? Image shrinker dot and you know what? I think I can't do that where I assign it here and then use it here. So I'm not going to bother. But don't worry. Oh, actually, you know what? Yes. Okay, we definitely need it when we set the new image. Where do we do that again? Here it is. Okay, so if the guys picked it and this is where we set the original image. So, okay, here's what we're going to do. Here's a new function called set original image, where you pass in a UI image, right, called image. And what does it do? It sets it. Okay. Right. Not only does it set it though, it sets it and it passes it through our handy dandy let image shrinker, which is an instance of an image resizer with our absurdly small max dimension of 64. Okay. So let's go back to image, set original image, and we're not going to do it directly. We're going to go through the image shrinker, and we're going to go dot resize image. There, that's not too bad. Let's see if that all compiles. What are you complaining about? Oh, I've already got something called set original image. No, wait a second. Set okay. Okay. So this is interesting. I've never seen this before, but I can kind of make sense of it. We have a we have something called original image, and this actually is, yeah, it looks like it won't let us give it that name. That's okay. Let's just call it set original. Huh, that fixed it, yeah. And I can kind of make sense of that. Okay, so set original, the guy passes in the image, we throw it through the shrinker, and then that's the image that we store. Cool. So now I can call this set original here. Right? And let's also do it right here. We're going to go, actually that's good enough. That's good enough. Okay, so let's run, because we don't care about this one. We don't care about the original image up there. We care about if we, actually now that I think about it, for demonstrating it, okay, let's do it. Let's go album, grab that, and I have a breakpoint I don't actually care about, so let's continue on. See how nice and blurry it is? That's because we shrunk it down to an ungodly level. But you remember how quick, how slow it was before? Now if we dither it, okay, that's an interesting effect, and it lets you see how huge those pixels are. So, anyways, that's our image. It's 64 by something. Absurdly, like I said, absurdly small. Let's not do that. Let's give it a more realistic dimension now. Let's go 1024. So on most devices, 1024, basically one of the dimensions will have to be less than 1024. It could be as small as 512. There's our original image. Let's go select that big mountainous picture. Let's go to our filter. Let's go dither. I didn't mean that. I meant dither. So we're always doing the same thing. And it is running. Wow, that was a lot faster. So it took that big image, scaled it down, and was able to apply the filter. So now we know filters will run fairly quick. Okay, thank you for attending this session, and I'll talk to you soon.